Welcome to section 2.2.2. We're going to be talking about equivalence once again. So Jonah and Graham were working together. Jonah says that x plus y squared is x squared plus y squared. Graham knows he's wrong, and he's right. Jonah made the most common mistake. You don't just square the first term and the last term. Remember, x plus y squared, if we write it out the long way, is x plus y times x plus y. So it's going to be x squared plus xy plus xy plus y squared, which would be x squared plus 2xy plus y squared. Jonah made the common mistake of missing that middle term. So now for 2, we're going to use the area model. We're not going to do this often. It looks like the box method, except now we have what's on the outside. We have a 3x and a positive 1, and we have a 2x and a negative 3. So we're just going to be multiplying. 2x times 3x is 6x squared. 2x times 1 is 2x. 3x times negative 3 is negative 9x. And 1 times negative 3 is negative 3. So then, once we have those values inside the box, we just combine like terms. 6x squared, negative 7x, and a negative 3. And there's our expression. Like I said, to me, it's more work than I think it's worth, so we're just going to multiply these the common way. Distributing the 5k, we're going to get 10k squared minus 5k. Distribute the negative 3, we get minus 6k, and then plus 3. So that gives us 10k squared minus 11k plus 3, and there is our equivalent expression. Now for part 4, A. 3x minus 5 squared. Now that falls in the case of a plus b squared. It's one of our special cases. So we get that we have a squared plus 2ab plus b squared. This is a quicker way to square binomials. Square the first term. When you square 3x, you get 9x squared. When you square negative 5, you get plus 25. And now the middle term is 2 times 3x, which is 6x, times negative 5 is negative 30x. And there is our equivalent expression. For part B, we're going to multiply. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is plus 10x. And then 5 times negative 5 is negative 25. So we combine, we get 4x squared minus 25. That's actually one of our special cases, and we call those binomials, we call those conjugates. They're in the form of a plus b and a minus b. So when we multiply those, where it's the same thing except for the one's positive and one's negative, you always get a squared minus b squared. And you can see that for part C, when we multiply, you're going to get x squared plus 3x minus 9, which is x squared minus 9. You can see they're conjugates, the same numbers, different signs. And now for part D, we're just going to multiply by distributing the 3x and then distributing the negative 1. So we get 3x squared plus 6xy minus 12x. And when we distribute the negative 1, we get minus x minus 2y and then plus 4. So when we combine, we get 3x squared minus 13x plus 6xy minus 2y plus 4. There's our equivalent expression. It's ugly, but that is our answer. Let's continue on with some more of these in the next page. Now, let's just skip number 9. I'm not really feeling these. So what we're going to do is we're going to go to factoring. And here's where the area model really helps, I believe. And this is what we've been doing all along. So what you can do is multiply 2x squared times 2. So we get 4x squared up top. And on the bottom, we have a 5x. Now, looking at numbers that multiply to 4x squared and add to 5. The top number's positive, so the signs are the same. Middle or bottom number's positive, they're both going to be positive. So the factors of 4, 4 and 1, or 2 and 2. To get to that positive 5, we need a 4x and an x. Now we have been using the box method, and we can still use it, but there's another method called grouping, and I'm going to show that now. So what you would do is you'd start off with the same thing, 2x squared the first term, and the last term is that positive 2. Now, in the middle go these two terms, just like the box. So we'd have a plus 4x and a plus 1. This is the box method without the box. So we look for the greatest common factor of the first two terms, which is 2x. So we factor that out, we get x plus 2. And in the last two terms, we can factor out a positive 1, and then we have our x plus 2. If you notice, they both have the x plus 2 in the parentheses. That's our common factor. X plus 2 goes out front. And then what's left over is 2x plus 1. This is called factor by grouping. You'd get the same exact thing if you use the box. Let's try another one. So multiply the first and the last term, so negative 30x squared goes on top, and the positive x goes on the bottom. So now, because the top number is negative, the signs are different. So the factors of 30, 6 and 5, 10 and 3, 15 and 2, we've got enough. Because to get that positive 1x, it's going to be a positive 6x and a negative 5x. So I'm going to use that grouping symbol, or grouping method again. So 2x squared, negative 15, and now these terms go in here. It doesn't matter which one goes first. So we're going to put plus 6x minus 5x. This is called the grouping method. Common factor is 2x. So we divide those terms by 2x, we get x plus 3. Now the last two terms, because this third term is negative, take out a negative. And in this case, a 5, and when we divide by negative 5, we get x plus 3. You see how in the parentheses is the same number? We're going to write x plus 3, and then we're left with 2x minus 5. And now, for D, I'm going to come back to C in a moment. So what we have here is we're going to multiply the first and the last. So we get negative 30x squared, negative 13x. Now the last number is negative, so the signs are opposites. One's positive, the other one's negative. Now the factors of 30, we already talked about 6 and 5, 10 and 3, 15 and 2. So now to get a negative 13, where both signs are different, we're going to use a positive 15x and a negative 2x. Oh, sorry, I flipped them. That's a negative 15x and a positive 2x. So now using our grouping method, the 3x squared and the negative 10, and in those open spots go our negative 15x and our 2x. So now the first two terms, the common factor is 3x. 3x times x minus 5. And now the next terms, because that third term is positive, we take out a positive 2. And then it's x minus 5. You can see in the parentheses is the same number, x minus 5. And then we're left with 3x plus 2. And now that is factored. Now for part C, you could use this method, or you could use a special case. 4x squared is a perfect square, and so is 49. So it's in that form of a squared minus b squared. So it's going to be a plus b, a minus b, the conjugates. So you could just factor it right away, and you'll get 2x plus 7 and 2x minus 7. If you didn't notice that, you could do the same thing we've been doing. Negative, so 49 times 4 is negative 196x squared. And now the middle term is 0x. So the last number is negative, so our signs are opposites. Now to get a 0 for the middle term, they have to be the same numbers. So it has to be a 14 and a 14. Those are the factors of 196. We'd have a negative 14x and a positive 14x. So it would become 4x squared minus 14x plus 14x minus 49. So looking at these, the common factors, we'd have a 2x, and we'd factor out an x minus 7. The last two terms, we'd have a positive 7, and then we'd have x minus 7. So now the common factor, x minus 7, oh, sorry, I didn't divide right. Those are 2x minus 7s. So in those parentheses, we'd have a 2x minus 7. And then when we factored those out, we'd end up with a 2x plus 7. I strongly recommend you know this special factoring pattern. It's going to save you a significant amount of time. It's so much easier if you know that pattern. Those are equivalent expressions. More factoring. We'll keep talking about factoring as the year goes on. That is it for this video. I will see you in the final part of Chapter 2.